Welcome back, I'm that chemist, and today we're going to talk about the chemistry of skunks. So, if you're not familiar with skunks, skunks are a mammal which are a little bit unfriendly because if they're feeling threatened, they can spray with their anal glands. Now, a skunk's anal gland is unlike the anal gland of other animals, as most animals tend to use this for identification. Like you see dogs that smell each other's rear end, and the reason for that is they have unique mixtures of chemical constituents which they're able to recognize from one individual to another. Now, skunks are an exception to this because they produce a unique cocktail of offensive smelling chemicals, which are almost entirely thiols. And it's noteworthy that these can spray up to 4 or 5 meters even. They can also spray up to 6 times in a row because they have a large amount of the oil in these glands that they can continue spraying. However, if they do spray, it takes them about 10 days to fully replenish their skunk load. Now, it's worth noting that the volume of the skunk stank that each skunk contains is approximately 15 milliliters, and it's actually amazing to me that skunks are able to contain this much thiol and that they could produce it this quickly. So here's a reference here if you want to look at it. Some of the science is wrong in this, but they do have some useful data that was referenced on Wikipedia. So if you see a skunk's tail go up, you know that you're about to go down. Now, you might be wondering, so skunks spray predators, but do they also spray each other? And so, usually not, but apparently if a female is getting harassed a bit too much by a male skunk, she might spray him, and apparently also skunks hate this smell, which is kind of ironic. So, she might be saying, I could smell his skunky rear end a mile away. Now, skunks stink for a number of reasons, and the majority of that smell comes from two specific thiols. There's also a third thiol, which is relatively abundant. However, it's overrepresented in a lot of sources because most sources won't tell you the specific amounts. So you can see some examples here, such as this alkene-containing thiol, which is actually the most significant component of skunk spray, making up 38 to 40% of the oil itself. Now, this similar looking one with an extra alkyl group and no alkene is the next most abundant component, and this is present in 18 to 26%. Now, in addition to these, there's a couple other thiols that are worth noting, including this quinoline thiol and some other trace ones such as phenylethyl mercaptan and benzyl mercaptan. It's kind of interesting to look at this other quinoline component of the oil, which is not sulfur containing, and you can see that this is likely just a precursor to the quinoline thiol compound. So you can kind of get a bit of an inference in terms of how this is made. Now, in addition to the thiols, there's also thioacetate derivatives. So here you can see a thioacetate ester, and these esters can slowly hydrolyze to form even more free thiol. And so while only one is shown here, there's several different thioacetate esters that could exist in skunk anal gland oil, although this will vary from species to species. You'll also be interested to know that there's this disulfide where you can see each of these two thiols is just connected together in this disulfide, which is kind of interesting. So the way that the ester is able to hydrolyze is first a nucleophile, which could be water, it could be some amine or sulfur residue in a peptide, such as that present in cysteine or proline, something in the hair or skin, can just attack and get acetylated by the thioacetate ester, which would then freely liberate a thiolate. This thiolate is then able to get protonated by a nearby proton, affording even more of this thiol. And so this is why, even after being sprayed, it's possible that the smell from the skunk could persist for months even, in some cases. So I'll give you one story. So when I was growing up, we had a dog. That dog's name was Peach. And one night, Peach went outside to go to the bathroom, and she was surprised by a skunk. And we didn't know that till we smelled the smell, and we were like, oh, I really hope that that is not our dog that just got sprayed. And sure enough, sad-looking Peach comes to the door, and she got sprayed. So we spent a bunch of time cleaning her, we showered her, bathed her, got rid of most of the smell, but she still smelled really bad. And she was kind of upset, but she went to bed fine, and we were a little bit frustrated, but that's fine. Next day comes along. Next night, she has to go to the bathroom before we put her to bed, and she got sprayed by the same skunk a second time, and she was a lot more upset, and so were we. And despite washing her with tomato juice, which is not effective, and we're going to get to what is effective in a little bit, we ended up trying to wash her with a bit of peroxide as well, and that helped a little bit, but the smell was still there. So we gave her a haircut, and despite the haircut, she still smelled like skunk oil for at least 8 months. It was no joke. So skunk smells are powerful, and hopefully when I tell you guys about the way to get rid of this, it'll actually help you guys out. So yeah, skunks are no joke, and because they can spray up to 6 times, that means if they get you today, they could still get you tomorrow if that skunk's still there. So I have some conjecture here, and I've found one source that backs me up, but it's just someone else having conjecture as well. If you have any attitudes or opinions about the mechanism of this, I'd ask you to comment down below or discuss it with me in the Discord. I'd be happy to know what you have to say on this. So initially, it's possible that thiols can form disulfides. If you've ever worked with thiols in organic chemistry, or if you're familiar with the chemistry of thiols, it's quite easy for them to form disulfides. Okay, and so it's possible that this disulfide is able to react with cysteine residues in proteins, forming a new type of disulfide, which then liberates more of the free thiol. And so this free thiol is going to be foul smelling. And so slowly, this can occur even more and form more thiol, but this is something that would take maybe weeks or months potentially. And so this is why this smell is there for quite a long time. Okay, so that's kind of just my conjecture, and so there's one reference here where someone claimed that a victim's hair or fur is going to smell for a long time because it probably chemically reacts with the proteins. Now, if you have any opinions about that, I'd like it if you could let me know down in the comments. So if you want to get rid of the smell, here's a neat trick. The mechanism of this is essentially you just have to oxidize the volatile thiols into something less volatile, like a sulfonic acid. And so here's a quick recipe. All you have to do is mix a quart or a liter of hydrogen peroxide, 3%, with 60 mils or about a quarter of a cup of baking soda, along with 5 milliliters of liquid detergent. And so you have to prepare this fresh because it will slowly give off oxygen. And the way this works is it just oxidizes the sulfur to the sulfonic acid, or sulfonate, I guess, because it's under basic conditions. Now, you could do it just with peroxide, but it won't be as effective as if you have the base and a little bit of detergent there. Okay, so this is the trick. If you want to clean up your dog, or if you want to clean up yourself, then that's a good trick. However, if you have any other affected items that aren't as sensitive, you can just wash them with bleach, and bleach tends to do a pretty good job. Now, if you like deepening your understanding of science, you should check out today's sponsor, Brilliant. Brilliant is a website and app that lets you learn interactively with a catalog of over 60 courses for people of all ability and knowledge levels. Brilliant has courses in many areas of STEM, including science, math, and computer science. Brilliant features courses with clear and intuitive explanations to help you actually understand the topics at hand. One course that you might want to check out is their course on chemical reactions. This course provides a straightforward introduction to chemistry that features beautiful illustrations and some of the main concepts in chemistry. Brilliant is offering 20% off an annual subscription to the first 200 viewers of this channel. You can get started today by visiting brilliant.org/thatchemist. I want to thank Brilliant for their support of this channel. So with that, I'd like to thank you for watching. It would really help out the channel if you could leave a like and subscribe, and I hope you have a great day.